Hey, welcome to the video. Today we're looking at slicing and lamination as techniques for building stage props, movie props, or other prototyping purposes. It's a great technique when you're able to create something with multiple pieces of the same material. And when you know the material thickness, you can predict how tall it's going to be and what is the resolution of the final product. So it's a technique that has a very distinct aesthetic. Each layer is essentially a two-dimensional contour with the height being the height of the material. And by stacking those layer pieces, you build up your prop, prototype, product, or whatever it is. It's used all over in sculpture, architecture. Here we can see it at Arcadia Earth in the Well in Toronto, designed to look like a face and a nose. And on the other side is a smell sample, which you can sort of stand in because it's about the size of a person. Then also the topographical map is a common application of this technique because the contour lines happen to match the contours of a mountain range, etc. I've also done this project with other students where we've rendered objects of their choice. This one is from Splatoon, got a great mask, an elephant, Bulbasaur, and a couple Yodas. So there are interesting ways to apply this technique. I've also built a movie camera with this technique using 1-inch foam, so a larger build for one-to-one real life scale, actually probably much bigger. And this technique allowed me to build something that was larger than what 3D printing could normally accomplish. So that's one big advantage of this technique. And I was able to integrate 3D printing as well and some laser cutting. So the parts of this camera shot that look like are thinner than the other parts. These parts were laser cut. This recording piece, this recording logo was 3D printed. And then the rest of the slices were cut. Now, because they're quite thick, in this example, I was able to do something like add some depth to one of the slices of the pieces. And you can see that we highlight the specific piece. There we go. Here, this piece. And this piece here has almost a completely two-dimensional contour, but I added some detail for it as well. When we go to take our model apart, what we end up getting are the individual slices. There we go. So we can see these slices arranged in 3D space so that we can manufacture each individual slice. So this is a time-consuming technique compared to some other techniques, but we can manufacture each of the slices individually, and so we have some creative control over the final product. Also, to make sure that the pieces fit together nicely, often we'll incorporate dowel pins or making something slightly asymmetrical so that we can imagine ourselves and finally accomplish putting together each of the slices aligned exactly as intended. So that's the movie camera example. We use the red rec or REC and the exaggerated reels to really highlight the fact that this is a video camera. Its main principle is recording, right? And so the features of this, as far as a prop goes, are emphasizing the fact that it is a lens, it has some sort of storage, and it is recording here. So those are the pieces of the design that really helped it stand out to be the thing that it was supposed to be. Over here, we can see a sculptural pencil holder piece, an abstract piece, and this interesting geometric shape is sliced for 3 mm plywood. Technically, it's 2.8 millimeters. And we get several layers here, probably about 2 dozen layers, that are then arranged onto the standard size sheet, ready to be laser cut there. So we can see we have a hole in there, and then our arrangement of these parts are optimized for the best arrangement onto the material. And we can preview that just by selecting the arrange feature created in this example. The material is intended to be 600 millimeters by 300 millimeters before it's laser cut. And so what we see here are the parts laid out by Fusion after it's sliced. Similarly, in this example, if we zoom in, we can find a pretty standard looking treasure chest. It has just the rectangular prism form with the half of a cylinder on top of it with some textural elements added to the front and back. So there are many repeated pieces in this design. And then you'll notice that the way in which the slicing is intersecting the half cylinder is actually going to result in some jagged step-like edges here, although it's still rounded as we slice it. Once this gets cut out of wood, we'll see this more like a stepwise motion. So one of the characteristic aspects of this style is that we get jagged edges instead of clean contours, and we slowly build up the contours, just how we see in this as well. It is technically jagged, although there are enough to make it start to look like a contour. And this is actually just how 3D printing works as well. Okay, and so the final step of this was to take it through the slicing template, which I'll introduce, and then to lay out the individual components on the standard cutting size that we're looking for, and to create the cutting outline. The purple is the final product, otherwise intended to use for laser cutting. The slicing template itself, or maybe we'll call it the cheese grater, is really just a series of lines created with a rectangular pattern with a plane at angle going through each one of them. Each one of the planes is set up to be the same distance apart as the material that you're trying to use. So if we check the parameters for my slicing template, I can see that the material thickness here is 2.8 millimeters, and this is a standard laser cut plywood material that I like to use. The target height is how tall I want to set up this ladder for here. And the target height divided by the material thickness, of course, gives me the number of layers. And then that gives me the number of layers tall that I need this ladder to be. Okay, so this is the template that we use to take a model and do the slicing technique with. So let's switch over to starting a new model with a new blank Fusion page or document. And good practice to save it now with Control S or Command S. And I'll save this as my example. And in this example, we are going to replicate the geometric pencil holder here. So we're going to make one that is 100 millimeters tall by about 40 millimeters in diameter, roughly. And we'll use the loft technique for that. And then we'll go over how to use the slicing template to slice it up. Okay, so back in the my example, we're going to go with a new sketch. And on that new sketch, I'm going to create the bottom of what my sculpture here is going to look like. I think I'll do it from a polygon that is circumscribed size. Circumscribed here means that there is a circle drawn in the inside of the polygon, and the radius of the circle is the size of it. So my radius here will be 20 millimeters because I wanted it to be about 40. And that's all I have to do to make this bottom face. Now to make the top face, I need to offset that. And here I'm using an offset plane. And this offset plane is going to allow me to set the height of the top face, and then we'll get Fusion to connect them together. So I said I wanted it to be 100 millimeters, so I'll set that. There we go. And then this plane I've created in space, I'm ready to create a sketch onto it. Okay, so note that the original polygon is below where I'm working, and the sketch plane that I'm working with that's shown, the grid that's shown, is where I actually am at. So it's always important to know where you are in 3D space. Okay, with this being the origin. So I want to reference the original shape first. And so to do that, I'm going to press P for project. And projection does something interesting. It's going to take this geometry and redraw it in my sketch. And to do that, it's going to draw an invisible line that is perpendicular from its plane with a normal. And it's going to draw that until it intersects with the intended sketch plane here. Okay? And so I'm just doing this so that I can redraw it here so that I can manipulate it for my upper face. The projection link is often useful for projection, but here, because I'm manipulating it, I'm actually turning off the projection link. So with my lower face copied onto my upper face, I'm gonna hit OK. And then one thing I can do to make a modification here is I can move it by double clicking it. And in fact, I'm gonna rotate it. So I'll select the rotation for the move type. And I need an axis here. So I'll turn on my origin folder because I'm centered on the origin. So I can use this central axis. And then I'll just apply a rotation to it. Okay. So I'll finish the sketch. And to make it easier, I'll turn the origin off. And then I'll use loft. And I'm using the solid body loft, which is the blue loft in that menu. And it's time to connect these two faces together. So already I've got the mass of something more abstract that's built on two basic opposing faces. I'll take the top sketch, and from here, if I just highlight it, I don't even need to edit it. I can start already manipulating it and switching it up and changing it around just to get a sense of what I like. Now, the bottom one, I don't have that same option because it's still constrained as a polygon. I can go into the sketch and I can delete the constraint that sets it as a polygon, or I can simply use this as a rotation. I think I like the look of what I have now. So I'm ready to hollow it out so that we could say use it as a pencil holder. I will, almost not typing pencil holder. The command I'm looking for is shell. Shell and the solid body one, which is blue. Okay, selecting the top face and setting the wall thickness to 3 mm. It's actually quite thin for uh, for this desk product, so I think that's a good match. And if I look around, what it's done is created a bottom of 3 mm and walls of 3 mm. So in this video, we talked about the loft tool to connect opposing faces and the shell tool to take a solid body and hollow it out, much like a cup. All right, that's all I need to do for creating my geometry for now. So if you're working with the lamination technique, you might have a totally different piece of geometry that you want to work with, or you're following along with this example. Okay, the slicing template, you're going to grab from the provided template or our class content, and I'm going to insert the slicing template into my example here. So I'll save my example. Normally, I can just click and drag it, and if that's not working for me today, then I can insert a component, and I will do the slicing template. Okay. So wherever it is positioned, as long as you started working on the original origin, you should be fine. Otherwise, you might have to move your geometry so that it intersects with the slicing template. And my height is good because it is smaller than the max set up for the slicing template. Now, in order to proceed, I need to break up this body into multiple bodies, as in each piece that would then, in my case, be laser cut. So I'm going to look at this orthographically from the side, and that's going to clear up that mess from the construction planes. And I'm going to split this body by finding the split body tool. There it is. It's a solid body tool. And the body of the split is my example. And the splitting tools are all of the construction planes that are provided in the slicing template that intersect with my geometry. Now, I don't need the first one because it is taken care of, but the rest I need. If you're working on a computer that is a little bit slow, then you might want to break this step up into chunks because it can uh, be a heavy operation for Fusion to complete. Not to miss any. And also only select ones that definitely intersect your part. Now, it doesn't matter that my part doesn't intersect where the planes are shown. These planes are actually infinitely long and wide. So as long as the part is vertically in line with these planes, it'll get cut. Okay, so if I open up my bodies folder, then I can see all of these bodies have appeared, which are the split. I'm going to just hide our template, and these lines show me that these are the individual slices now. So that's very good. The next step is to convert all of these bodies into components so that I can arrange them how I need. Converting them to components really just moves them into their own individual invisible box or unit of organization. Right now, they're all sub bodies for the main file, which is its component. So it's an organizational structure in CAD. Selecting all the bodies, right-clicking on them, and going to create components from bodies. Now all of the bodies are components. And if we just pop in here, each component has its own body folder, which was one of the bodies. Okay, so now it's time to arrange these parts. Arrange. And arranging is a cool tool because it allows you to take these parts and position them into a size that you determine in the most efficient way possible for cutting. So it's a great way to make the maximum use of material. I'm going to start by defining the envelope or my cutting area. And for me, my envelope is going to be a plane. That plane, I'm going to use the bottom origin plane for that. If that's not on for you in your design, you can find a bottom origin plane, or you might have to turn the origin folder on to see that. So my plane is selected. Now I need to tell it a little bit about what I'm looking for. And I'm looking for a length of 600, a width of 300. There will be no offsets. You can allow partial arrangements, that's if they don't fit, but I recommend just keeping an eye on that because you need to make sure all of your parts have been arranged successfully. The placement clearance for laser cutting can be 0 because the kerf is very small. And then the frame width, it's helpful to have just a little bit of buffer around the frame to just accommodate for whatever is needed in the process. And then object spacing as well. For our purposes, we don't really need any spaces between the objects, so we'll turn that off by entering it as 0. And the space between envelopes can be 3 as well, just arbitrarily. Okay, so then I need to go and I need to select the bodies, rather the components that will go in there. I can start with the first one, and you can see Fusion starts arranging them, and I'll just select all of them. There we go, they're arranged. So looking at my roughly 1 foot by 2 foot piece of material, 600 by 300 millimeters, I can see that I need about half of it in order to create the shape that I wanted to create. So I'll click OK. And then there's only one more step to really get this ready for laser cutting, which is to take these arranged parts and define their outline so that that outline can be sent to the laser cutter. So we need one more sketch, and that sketch should be on the bottom plane of the origin there. This is right here for me. Okay. And working on this bottom plane, I'm going to get Fusion to draw the outline of all of these parts. So to do that, I'm going to project them. And I can project just their bodies. Just their bodies. There we go. And I'll have to go through and click on each part. So this technique can be a little bit tedious, but it also does get you really familiar with each of the parts, what their shape is, what you're manufacturing, how it's going to come together. So it's part of the fun and part of the process of building something is understanding it at a small detail, and lamination definitely gives you that. There we go. So I can finish that sketch. Now I had projection link off there. In reality, I should have had projection link on so that if I made a change here, all of this would change. But if we look back at the final sketch that we made right here, we're ready to go with laser cutting this and sending this to the laser by right clicking on it and going to save as DXF. And then we've got a file that will work for generating this model. Okay, thanks for watching the intersecting slice tutorial.